Okay, this video is about the quadratic formula. So, in a previous video, we've learned about completing the square. And completing the square lets us solve quadratic equations. So we've seen factoring. Right? Factoring can be used to solve quadratic equations, but there's a downside to factoring, which is that it only works if you can easily factor it. And there are some quadratics that you can't, even if you did factor it, it wouldn't help you solve the equation. But completing the square does work, and it works for any quadratic. So we're going to complete the square for any quadratic equation and solve it. So completing the square is the basis for the formula that we're going to get, the quadratic formula. Okay, so let's just look at an example. Well, we're not going to do out this example. It's just to illustrate something we might want to solve. So for instance, let's say you want to solve negative 2x plus 7x minus 6 equals 0. And well, if you wanted to solve that, then one thing you can always do, I see that the coefficient of x squared is negative 2, that's negative. If you want, you can always divide both sides by negative 1 to simplify things. So if I factor out a negative 1, I'm going to get 2x squared minus 7x plus 6 equals 0. And then I divide both sides by negative 1, and then that will give me 2x squared minus 7x plus 6 equals 0, right? Because 0 divided by negative 1 is 0. Here I divide by negative 1. So whenever you have a quadratic equation like this, you can always just factor out the negative 1 and then divide out the negative 1 to guarantee that the number in front of x squared is positive. So let's talk about, so can always assume that a is positive. You can always get to this stage. So let's say that you have a quadratic equation and you want to solve, and you get to the stage where the number in front of x squared is positive. Then how do you solve it? Well, let's figure out a general formula for this. So let's try to solve the equation ax squared plus bx plus c equals 0, where a is a positive number. And it's going to be based on completing the square. So first, we want to get something that's in that format where we can complete the square. So we'll subtract c. That's the first step. Subtract c on both sides. And then we'll divide both sides by a. So let's just, okay, so to write all the steps, I'm going to factor a out. And this will leave me with b over a times x equals negative c. Right, I just factored out an a. And then I divide both sides by a, and I get x squared plus b over a x equals negative c over a. Now, I'm ready to complete the square. I'll do completing the square to this. And my coefficient in front of x is b over a. So I take the number that's in front of x, right? I have this x squared plus a constant times x. I take the constant that's in front of x, I divide it by 2, that leaves me with b over 2a, and then I square it. And when I square it, I will get b squared over 4a squared, right? Because, should I just show it all the steps? Because this is equal to, by the exponent properties, this is equal to b squared all over 2a in parentheses squared. This is b squared over, okay, 2a times 2a is 4 times a squared. So I need to add b squared over 4a squared to both sides. And now I can factor the left hand side, that's the point of completing the square. This is x plus b over 2a in parentheses squared. And then on the right, this, okay, I need to get a common denominator. I have a fraction. This I'll just multiply top and bottom by 4a, so this will be negative 4ac over 4a squared. And so I get b squared minus 4ac all over 4a squared. Okay, now I have something, this thing, in parentheses squared equals something. And so now I can say what the inside is. Well, there's a bit of a catch. So notice that 4a squared here is positive. Like this 4a squared is positive. Now the b squared minus 4ac may or may not be positive. And notice that the left-hand side, I have something squared. So it's always going to be greater than or equal to 0. So if b squared minus 4ac is negative, then I won't be able to solve this because the left-hand side will never be negative, but the right-hand side will be negative. So if b squared minus 4ac is less than 0, the equation has no solution. Let's call this equation. Let's just put a star next to this. So this starred equation has no solution, has no real solution. But if b squared minus 4ac is greater than or equal to 0, we can keep going, because from this equation we get that x plus b over 2a, there are two possibilities for this. It's plus or minus the square root of b squared minus 4ac over 4a squared. Well, we're almost done. We can use the property of square roots. This is the square root of the top over the square root of the bottom. Now a is positive, so the square root of 4a squared is just going to be 2a. And the last step is to subtract negative b over 2a on both sides. And if I do that, I get this. And if I want, I actually have a common denominator, so I can combine the numerators like this. And now we solved for x. This is the solution if b squared minus 4ac is greater than or equal to 0. But how do we know that these are actually solutions? Okay, let's check that. The reason why these are solutions is because if x is one of these numbers, you can reverse the steps. So if x is equal to this, okay, then x plus ba is equal to this, which is equal to this. And if x plus b over 2a is equal to this, then x plus b over 2a squared is equal to that. And then you can just undo the algebra steps to get ax squared plus bx plus c equals 0. So that shows that these are actually solutions. And what we showed is these are the only solutions. So the theorem, the quadratic formula, is to solve. So the solutions to ax squared plus bx plus c equals 0, where a is positive, is, well, there's no solution if b squared minus 4ac is negative, and I mean no real number solution. But if b squared minus 4ac is greater than or equal to 0, the solution is negative b plus or minus the square root of b squared minus 4ac over 2a. So that's what we showed. And we used the quadratic, we used completing the squares to figure this out. Okay. Okay. So let's just do a quick example. Let's say you wanted to solve do I have an example off the top of my head? 4x squared minus 20x minus 7 plus 17 equals 0. All right. Well, to do this, we can use the quadratic formula. We just need to figure out what a, b, and c are, and then we can just plug it into the formula. So in this case, what's a? Well, a is 4. What's b? Well, b is actually negative 20, not positive 20. Because when you look at this, right, it's ax squared plus bx plus c. Here, I need to write this as 4x squared plus negative 20x plus 17. And so my a is going to be 4, my b is negative 20, and my c is 17. So now I just plug it in. I get x equals negative b, that's negative 20, right, negative 20, plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, what do we get? This is x equals negative 20 is 20. Negative 20 in parentheses squared is 400. And then I have minus 4 times 4 times 17. And that is 272. This all over 2 times 4 is 8. Now I'm ready to simplify this more. 400 minus 272 is 128. Okay, all over 8. And I can simplify this more by pulling out squares in from the radical. So let's see, I think the biggest square I can pull out is 64, right? Because 128 is 64 times 2. So if I pull out a 64 from the square root, I'm going to get 8 times the square root of 2. This all over 8. And this is going to be, see, I have a common factor of 4, right? So this is going to be, I can factor out a 4. I get 5 plus or minus 2 root 2 all over 8. And so this is going to be 5 plus or minus 2 root 2 over 2. So therefore, x is 5. So the solution is x equals 5 plus 2 root 2 all over 2, and x equals 5 minus 2 root 2 over 2. These are the solutions to the equation. And that's an example of how to use the quadratic formula. And I just want to emphasize that how did we get the quadratic formula in the first place? We did it by completing the square. So it really is important to know how to complete the square in order to understand how all of this works. Oh yeah, so here we were assuming that a is positive, and we needed a to be positive in the explanation of how this worked to get from the square root of 4a squared to 2a. Right? This is true if a is positive. If a is negative, then the square root of 4a squared would be negative 2a. Because if a is negative, then 2a is negative, right? So you need to multiply by negative 1 to make it positive. But if you think about it, if you change if a is negative, okay, then the only difference is that the square root of 4a squared is going to be negative 2a. Now, if you have plus or minus, okay, something over negative something, like let's just look at an example. Let's say that you had plus or minus 6 over negative 5. Well, this is going to be the same as 6 over negative 5, comma negative 6 over negative 5. And that's the same as negative 6/5, comma 6/5. Okay? This is the same as plus or minus 6 over 5. And the same reasoning shows that this is plus or minus this over negative 2a is the same as plus or minus the square root of b squared minus 4ac over 2a. So in fact, this is true, this equation is true no matter whether a is positive or negative. What this negative sign will do is that it's just going to change the plus or minus to a minus and then a plus. But if you have minus something or plus something, it's the same as plus something or minus something. So these two values of x are the same. So actually, we don't need that a is greater than 0. The formula will still apply regardless of what a is, as long as it's not equal to 0. A can be positive or negative, and the formula will still work. Okay, that's all I wanted to say in this video.